Hello, welcome to the fall of 2017 Group 2's IE 441 Senior Capstone Project through Iowa State's IMSE department. We worked with Cardinal Glass, a glass manufacturer for windows and doors. They apply the latest in glass science to create insulated, coated, laminated, tempered, or just plain float glass. They are a supplier to large window manufacturers such as Andersen and Pella. Cardinal has 40 manufacturing plants around the U.S. Our team worked with the plant in Greenfield, Iowa, where they were experiencing a lack in throughput within their glass tempering process. They currently average 11,300 square feet of glass per shift and gave us a goal to increase their throughput to 13,500 square feet per shift.
Our areas of interest included conveyor bed width batching and recipe changes. To better conceptualize batching, it is important to understand how the glass is cut prior to being batched. An operator receives pending orders on the computer. They continuously place the orders into a virtual pool of orders that are to be run soon. Then at the cutting table software automatically pulls from the pool and automatically fits the orders to be cut from a large stock sheet of glass. It is important to note that right now this software is built to prioritize one thing: yield. Everything not cut is essentially thrown out. This software largely dictates the rest of the downstream. From here, for a simplified understanding, the glass is then transported down a series of automated conveyors to the TAM furnace, where they are treated with gases and heat and then unloaded after tempering is complete. The conveyor's bed width is 84 inches wide. At best, it can fit 80 inches of glass across it. Ideally, the bed width would be totally utilized, but we found that oftentimes single and double lights are sent to the TAM that could have easily been part of a triple had the cutting software been programmed to account for it. After collecting production data, we were able to calculate that on average, Cardinal was running around 2,161 batches through the TAM in a day. We then created a formula to show a conservative number of batches Cardinal could theoretically do in a day, totaling 1,424 batches, a 34% decrease in batches required for the same daily production. Taking into account Cardinal's rework requests, this results in a 16% increase in throughput, or an additional 1,875 square feet per shift. The second solution revolves around something called a recipe. All glass that runs through the TAM has a recipe that the TAM software recognizes and applies. A recipe is a combination of the gas, heat, and conveyor speed that are applied to the glass inside the TAM. There are roughly 50 unique recipes, and around 35 different recipes are run in a given day.
Currently, at the cutting tables, there is no standard method of ordering recipes with respect to the TAM's throughput. Now, the cutting table pool is ordered according to each recipe's TAM cycle time. Here's an example. If recipe Y has a 15-minute cycle time and recipe X has a 10-minute cycle time, recipe X will have to wait for recipe Y to prevent overlapping, as well as for the TAM to change to meet recipe X's required temp and gas settings. Then recipe X may enter. One of our goals was to eliminate all unnecessary recipe changes.
One obvious example, and our third solution, is that as a result of their automatic work scheduling, a given recipe may be run multiple times within a shift. Here, the repeat of recipe 3 involves an unnecessary recipe change. While still working within Cardinal's required order lead times, we were able to prove that grouping instances of the same recipe together would increase a shift's throughput by about 306 square feet.
Utilizing both of these solutions would result in an increase of 2,897 feet squared per shift, which would increase the shift average from 11,650 feet squared per shift to 14,547 feet squared, which is well above the goal of 13,500 feet squared. Assuming no yield loss, this could save Cardinal $469,332 per year.